It's easy to imagine terror birds only in South America, but one species actually spread its wings all the way to Europe. These feathered nightmares emerged from the ashes of the dinosaur extinction. They carried the torch of their terrifying predecessors, proving that nature abhors a vacuum, especially when it comes to apex predators. Roughly 53 million years ago, in the early Eocene, the world was a very different place. It was a hothouse with lush forests stretching from pole to pole, filled with a diverse range of life forms that emerged after the extinction of the dinosaurs. It was in this steamy prehistoric paradise that the first terror bird, Paleopsilopterus, made its debut. Standing at a modest height of 1 meter or 3 feet, this Brazilian bird might not have seemed particularly terrifying at first glance. In fact, it was about the same size as a modern-day stork, hardly the stuff of nightmares. But appearances can be deceiving, and Paleopsilopterus had something its contemporaries lacked: potential. What set Paleopsilopterus apart was its agility and speed, traits that would become hallmarks of its descendants. While it may not have been the apex predator of its time, dwarfed by monstrous crocodilians and giant snakes, it was a harbinger of things to come. Little did the other inhabitants of ancient South America know that they were witnessing the birth of a dynasty that would reign for millions of years. As the Eocene progressed, so did the terror birds. Nature, it seemed, had plans for this lineage of avian predators, and those plans involved getting bigger. Much bigger. Just 3 million years after Paleopsilopterus took its first steps, a new player entered the scene. Eleutherornis, a terror bird that stood 50% taller than its ancestor, emerged as a formidable predator. But Eleutherornis wasn't content with merely growing in size. It also expanded its range in a way that no other terror bird would match. While most of its kin would remain firmly rooted in the Americas, Eleutherornis spread its wings and ventured across the sea to Europe. Fossil remains of this globe-trotting terror have been found in both France and Switzerland, making it the only known member of its family to have lived outside the New World. I can only imagine the surprise of early European mammals when this exotic predator appeared in their midst, bringing a taste of South American terror to the Old World. But Eleutherornis was just the opening act. As the epochs rolled by, the terror birds continued to grow, adapt, and diversify. It was as if they were engaged in a relentless competition with themselves, each new species trying to outdo its predecessors in size and ferocity. The Oligocene epoch, spanning from about 34 to 23 million years ago, marked a turning point in the terror bird saga. It was during this time that the family truly began to live up to its name, with the emergence of giants that would have given pause to even the bravest of prey, the Paraphysornis. This Brazilian bird was an absolute behemoth that stood 1.4 meters, or 4.5 feet tall, and tipped the scales at a whopping 180 kilograms, or 400 pounds. To put that into perspective, Paraphysornis outweighed the largest living bird today, the ostrich. This was no lightweight contender. Paraphysornis was built like a feathered tank with robust bones that spoke of raw power. Paleontologists believe that Paraphysornis hunted using a combination of kicks, slashes, and powerful jabs with its sharp beak. It's a hunting style that might remind one of a prehistoric version of mixed martial arts, with Paraphysornis as the undefeated heavyweight champion of its time. But Paraphysornis wasn't just a mindless brute. Like many of its terror bird kin, it likely possessed a level of intelligence that set it apart from other contemporary predators. Studies of terror bird brain cases suggest that they had well-developed visual and auditory centers, indicating keen senses that would have made them formidable hunters. As impressive as Paraphysornis was, it was merely setting the stage for what was to come. As we step into the Miocene and Pliocene epochs, spanning from about 23 to 2.5 million years ago, we encounter the true giants of the terror bird family. These were creatures that pushed the boundaries of what it meant to be a bird, reaching sizes that rivaled the predatory dinosaurs of old. Three names stand out in this pantheon of avian terrors: Titanis, Kelenken, and Brontornis. Each of these genera represents the pinnacle of the terror bird lineage, and each had its own claim to fame. Titanis, the youngest and smallest of the trio, was also the most adventurous. While most terror birds were content to dominate South America, Titanis had grander ambitions. It crossed the newly formed land bridge connecting North and South America during the Great American Interchange, becoming the only large South American predator to successfully establish itself in North America. Unlike most of its relatives, this bird lived in what is now the United States, including the states of Texas, Florida, and California. Standing 2 meters or 6.6 feet tall, Titanis would have been an imposing sight for the mammals of North America. Imagine the shock of a Pleistocene horse or ground sloth, accustomed to watching out for saber-toothed cats and dire wolves, suddenly confronted by this alien predator, half bird, half nightmare. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 3 meters, or 9.8 feet tall, and weighed around 250 kilograms, or 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse, and a beak that could crush bone. I have been fascinated by the terror bird's skulls. Recent studies have shown that Kelenken and other large terror birds possessed a unique skull structure. It set them apart from their smaller relatives. This adaptation gave them increased bite force and pecking power. This suggests to me that these giants may have been capable of taking down larger prey than previously thought, potentially including some of the megafauna that roamed South America during their reign. But the title of the largest terror bird is still hotly debated, with Brontornis giving Kelenken a run for its money. While slightly shorter at 2.8 meters, Brontornis was built like a feathered bulldozer, potentially weighing up to 400 kilograms. This made it not just the heaviest terror bird, but also the heaviest carnivorous bird of all time, and the 4th heaviest bird overall. Interestingly, Brontornis has been the subject of scientific controversy. Some paleontologists have questioned whether it was truly a terror bird or even a carnivore at all, citing similarities in its toe claws to those of herbivorous birds. However, recent studies have identified features in Brontornis's vertebrae that are unique to terror birds, lending weight to its classification as a member of this fearsome family. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians. The ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terrorbirds versatile predators capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry. While their imposing size and fearsome beaks often steal the spotlight, the true power of terrorbirds lay in their highly developed senses. Recent studies of terrorbird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terrorbirds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But what really set terrorbird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. As for their hearing, the inner ear structure of terrorbirds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. Imagine a terrorbird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. To a casual observer, it might appear to be resting or even dozing. But in reality, every fiber of its being is alert, its incredibly sensitive ears picking up the faintest rustle of leaves or the softest patter of tiny feet. In an instant, it can pinpoint the location of its unsuspecting prey and launch into action. This combination of visual and auditory prowess made terrorbirds the complete predatory package. It's no wonder these birds were able to dominate their ecosystems for millions of years. But even the mightiest rulers faced their downfall, and the reign of the terrorbirds was no exception. For millions of years, these avian predators had ruled supreme in South America, developing into a diverse array of species that filled various ecological niches. But somewhere along the line, their luck ran out. Traditionally, the extinction of the terrorbirds was linked to the Great American Interchange, a major paleozoographic event that occurred about 2.7 million years ago. This event saw the formation of the Isthmus of Panama, creating a land bridge between North and South America. As a result, animals from both continents were able to migrate across this newly formed connection, leading to a significant reshuffling of fauna. The conventional wisdom held that the influx of new predators from North America, including cats, dogs, and bears, outcompeted the terrorbirds, leading to their eventual extinction. It was a neat and tidy explanation that seemed to make perfect sense. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors. The terrorbirds. I've always been fascinated by their downfall. It wasn't simply a case of bigger, stronger predators arriving and taking over. The fossil record reveals a far more complex story. Most terror birds, and many of their South American competitors, had already vanished long before placental predators arrived in significant numbers. It seems something else was at play, something beyond simple competition. The success of Titanis in North America always struck me as a powerful counterpoint. It expanded its range northward and coexisted with large canids and felines for millions of years. This suggests that at least some terror birds were more than capable of holding their own against mammalian predators. So, if competition alone didn't doom them, what did? As is so often the case in paleontology, the answer likely involves a complex interplay of factors. Climate change, in particular, may have played a significant role. From the Oligocene to the Pliocene, Earth's climate was on a long-term cooling trend, culminating in a series of ice ages. This global cooling would have profoundly impacted the ecosystems that terror birds called home. As temperatures dropped and habitats changed, the lush forests that many terror bird species relied on would have given way to more open grasslands. While some may have adapted, others struggled. The larger, more specialized species, in particular, might have found it difficult to find enough prey to sustain their massive bodies. In these changing environments, the influx of new competitors from North America, while perhaps not the primary cause of their extinction, would have added additional prey to already stressed populations. Despite the challenges, the terror birds proved remarkably resilient. Recent discoveries have pushed back the date of their extinction much further than previously thought. It paints a picture of a group of animals that fought beak and talon to survive in a changing world. For years, it was believed that terror birds had gone extinct around 1 million years ago. However, new fossil evidence has dramatically altered this timeline. Some smaller species of terror birds have now been dated to as recently as 96,000 years ago. A mere blink of an eye in geological terms. The lion may be the king of the jungle, but the tiger stands out as the largest, most powerful, and most skilled of them all. But there was one species in particular that stood above them all. Not only did it dwarf the modern tiger in size, but it ranks among the largest cats to ever exist, the Nandong tiger. In the early 20th century, Dutch paleontologists excavating near the village of Ninggandong on the island of Java in Indonesia found something that stopped them in their tracks. They unearthed a collection of bones that belonged to a tiger. However, it quickly became apparent that these weren't regular Bengal tiger bones. These were bigger than anyone in the modern world had ever seen. Further research and analysis of additional fossils revealed even more astonishing details about this strangely huge tiger. For thousands of years during the Pleistocene epoch, the Gandong tiger roamed the Sundaland region of Southeast Asia, striving to establish itself as the dominant apex predator. This formidable beast was larger than its modern-day counterparts, with adults weighing up to 20 to 25% more than the average present-day Siberian tiger. Larger males typically weighed upwards of 400 kilos, making them close contenders for the title of largest feline ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. However, a look through history tells us something completely different. Tigers haven't always been this big. Early tigers, existing long before the Nyandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied. A smaller body size offered energy conservation and agility advantages across various terrains. So the early big cats related to tigers, such as Panthera paleosinensis, likely averaged around 70 to 120 kilos in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I often think about what it means to be an apex predator. To rule the wild, to stand at the top of the food chain. It sounds like a life of dominance. But the truth is, even the most fearsome hunters aren't necessarily the biggest. Size isn't everything in the predator game, though nature sometimes creates carnivores so specialized, so perfectly adapted to hunting big game, that they seem almost mythical. One such beast was the Ngandong tiger. Weighing in at a hefty 110 to 150 kilo, this tiger prowled the earth from the early to middle Pleistocene. Its remains were first discovered in what we now know as Indonesia. As time marched on, the Wanyan tiger emerged, holding sway from the late Pliocene to the middle Pleistocene, boasting an even more impressive weight range of 200 to 350 kilograms. This gradual increase in size over millennia can be explained, at least in part, by the fierce competition for food among large carnivores. A surprise or flank attack, exploiting their limited agility and targeting vulnerable areas, would have been the tiger's only real hope. The Nyandong tiger likely found more success with herbivores like Rusa timorensis, Malayan tapir, giant rats, gibbons, and wild boars. Despite these difficulties, the Gondong tiger earned its place as one of the most impressive predators of all time. Its smart hunting skills, ability to target weaker prey, and even scavenge demonstrate its adaptability and toughness. This allowed it to thrive for millennia until the extreme climate shifts of the Pleistocene epoch. These shifts brought periods of intense cold, with vast ice sheets locking up water and lowering sea levels, followed by warmer periods with melting glaciers and rising sea levels. As a result, Sunderland was fragmented into smaller islands, leading to isolated populations of Nyandong tigers with limited resources and genetic diversity. From these isolated populations emerged smaller subspecies of tigers, such as the Sumatran tiger, Bali tiger, and Javan tiger. While climate change undoubtedly played a role, some scientists believe that the presence of early humans in Southeast Asia might have also contributed to the tiger's extinction, causing increased competition for resources or potential conflicts. Other factors may have contributed as well. But with limited fossil records, we are left with many unanswered questions. Imagine a cat the size of a bear, capable of leaping over a one-story building. That's the image that comes to mind when I think about Smilodon, the saber-toothed cat of the Ice Age. It's a name synonymous with extinct predators, thanks in no small part to films like Ice Age. But its story began long before Hollywood immortalized it. It all started about 160 years ago in Brazil, with a discovery that initially baffled scientists. The first Smilodon remains weren't recognized as belonging to a cat at all. Based on some isolated cheek teeth, paleontologists initially thought they'd found a new type of hyena, and they dubbed it Hyena neoga. Within a few years, however, a flood of new fossils emerged. Foot bones, skull fragments, and those iconic, almost comically oversized canines told a very different story. It became clear that this was no hyena. It was a completely new genus of felid, massive in size and built like a prehistoric tank, far more robust than any modern cat. Thus, Smilodon populator was born, with Smilodon meaning knife tooth and populator roughly translating to the destroyer. It's a fitting name for a predator that redefined lethal. The scientific community then dove into unraveling Smilodon's family tree, a quest that continues today. Researchers place our knife-toothed friend in the extinct subfamily Machairodontinae, home to most of what we call saber-toothed tigers. Though saber-toothed cats is more accurate, as these ancient felines aren't closely related to modern tigers, or any living cats for that matter. Their closest living relatives might be members of the Felinae subfamily, which includes our domestic kitties. Within the Machairodontinae, Smilodon belongs to an even more exclusive club, the Smilodontini, or dirk-toothed cats. This group is pretty exclusive, with only 5 known genera. But what Smilodontini lacks in diversity, it makes up for in star power, thanks to Smilodon. As research progressed, scientists discovered that Smilodon wasn't a lone standout. It was more like a prehistoric trio, with 3 distinct members, S. gracilis, S. fatalis, and S. populator. If you came face to face with any of these species, you probably wouldn't be too concerned with which one was about to turn you into lunch. But they did have their differences. S. gracilis was the elder statesman, appearing in North America about 2.5 million years ago, descending from an even older genus called Meganterion. S. fatalis strutted onto the scene roughly a million years later, and S. populator made its grand entrance about 600,000 years after Fatalis, fashionably late to the Ice Age party. S. gracilis, while no slouch, was the runt of the litter, weighing about the same as a modern jaguar. S. fatalis, living up to its name, was a step up in the terror department, matching an African lion in size, but packing extra muscle, weighing in at around 280 kilos, or 620 pounds. That's on par with the largest tigers roaming the earth today. But S. populator dominated them all. This behemoth pushed the boundaries of felid physiology, with the largest known specimens estimated to have weighed in at a jaw-dropping 470 kilos, or 1,040 pounds. That's about the same as a medium-sized polar bear. Interestingly, unlike many modern big cats, Smilodons didn't seem to be too hung up on gender norms. Studies suggest that there wasn't a significant size difference between males and females, a trait scientists call low sexual dimorphism. In practical terms, this means that whether you were facing a male Smilodon or a female Smilodon, you were in for equally big trouble. Smilodon wasn't just large. It was built like a prehistoric tank. The Smilodon's heel bone was a marvel of natural engineering, robust and elongated. Some paleontologists speculate that these Ice Age acrobats could have outjumped modern lions, which have been observed clearing heights of 15 feet or 4.5 meters. And if modern big cats have arms that could crush you, Smilodon's forelimbs took it to the next level. We're talking about limbs that were approximately 20% thicker than what you'd expect for a cat of its size, giving it incredible strength, surpassing even that of the larger American lion. At the end of those muscular arms, Smilodon was further armed with fully retractable claws, razor-sharp and curved like prehistoric scimitars. They were proportionally enormous, even for a cat of Smilodon's size, twice the size of a Siberian tiger's. Those impossibly long canines. They've captured imaginations for generations, haven't they? I know they certainly captured mine. Nature has played around with the saber-toothed design in various mammals, even non-mammals, but Smilodon, it perfected the concept. What made its fangs special wasn't just their presence, but their audacious length. We're talking about canines so long they protruded well beyond the lower jaw, a feature that was uncommon even among other saber-toothed cats. They could grow up to 8 inches long, longer than many modern kitchen knives, precision instruments of prehistoric destruction. These teeth were shaped like deadly daggers with sharp points and smooth, narrow sides, designed to pierce deep into flesh with devastating efficiency. You'd expect a predator with teeth like that to have a powerful bite to match. But surprisingly, studies have shown that Smilodon's bite was relatively weak, about 4 times weaker than a modern lion's. So how did it kill? Well, that's been a subject of much debate. One popular theory suggests that Smilodon was the original ambush predator. I picture it hidden in dense vegetation, waiting for the perfect moment. This suggests that not only were they quick on their feet, but they were also willing to risk life and limb, or at least a bruised chest, in pursuit of their next meal. Smilodon's unique traits, along with its powerful weaponry, made it a versatile hunter capable of taking down a wide variety of megafaunal prey. The specific animals it targeted varied based on the region it called home. In North America, their prey included oversized versions of animals we recognize today, giant bison, camels, and, if the opportunity arose, even mastodons and Columbian mammoths. Yes, these cats were taking down creatures that dwarfed modern elephants. In South America, Smilodon's targets were equally impressive and diverse, including creatures like Toxodon, Litoptona, various species of Glyptodont, along with more familiar animals such as horses and camelids. Some evidence even suggests that Smilodon occasionally went after caimans, cementing its status as a top predator. We know what Smilodon ate thanks to skeletal evidence such as tooth marks on bones, or Smilodon remains found alongside those of their prey, providing vital clues about its diet. One big question that's still hotly debated in paleontology circles is whether Smilodon was a lone hunter or a team player. This isn't just academic curiosity. Knowing whether Smilodon hunted in packs could tell us a lot about its social structure and what kind of prey it typically targeted. One of the strongest pieces of evidence supporting the idea that Smilodons lived socially comes from the La Brea tar pits in California. These California tar pits are a gold mine for paleontologists, preserving countless Ice Age animals that got stuck in the sticky asphalt. But most of the bones found in La Brea aren't from herbivores that got trapped. but from predators that got stuck trying to eat the trapped herbivores. Smilodon fossils are the second most common find in these pits, with over 166,000 bones attributed to it. This high number has led some scientists to suggest that Smilodon might have been a social animal. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group who then also got stuck. It's a grim thought, but it could explain why we find so many Smilodon remains in one place. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching, though in a prehistoric, slightly grim sense. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodons. The idea is that these injured. Imagine a Smilon with hip dysplasia, somehow surviving to adulthood in the Ice Age. Evidence from La Brea suggests that dire wolves would frequently abandon their kills when a Smilon showed up. I can understand why. Those sabers on full display would probably make most predators think twice. But it wasn't just lions and wolves. The Ice Age was also the time of the short-faced bear, a beast that could make even a Smilon look small. Some of these bears reached truly dinosaurian proportions. Still, they were more omnivorous than the Smilon, which likely reduced direct competition. Plus, bears tend to be solitary. So, if a group of Smilons encountered one, the bear would likely have decided it wasn't worth the trouble. We've talked about the Smilon's hunting adaptations, but how did it even eat with those teeth? Those saber-like fangs seem like they'd be an obstacle. Well, the Smilon had a solution. Unlike most predators that chomp from the front, it had specialized slicing teeth called carnassials. These teeth, on the sides of the mouth, worked like biological scissors, shearing through meat. To eat, the Smilon would turn its head to the side, using these carnassials to slice off manageable chunks, while its saber teeth stayed out of the way. It's a technique you might have even seen modern cats use, a prime example of nature's problem-solving. With its adaptations and hunting prowess, the Smilon carved out a vast empire. Between its three species, it achieved a distribution across the Western Hemisphere that would make any modern predator envious. Given that Meganterion, a possible predecessor of the Smilon, was known to occasionally prey on Homo erectus, it's not a stretch to imagine that the Smilon might have considered early humans as potential prey too. It's extraordinary to consider that humans once shared the landscape with creatures like Smilodon. A petroglyph discovered in 2021 seems to depict a group of humans observing one from afar. It's a tantalizing glimpse into that shared world, a world that, as we know, wouldn't last. Around 10,000 years ago, Smilodon disappeared. That's roughly the same time that humans in some parts of the world were developing agriculture. The reasons behind Smilodon's extinction continue to be debated among paleontologists. Some believe that humans played a significant role, either through direct competition or by altering habitats through practices like controlled burns. Others are less convinced of our impact. The more widely accepted theory points to the broader quaternary extinction event as the primary cause. This period of significant climate change led to the disappearance of many large animal species in North and South America. As the megafauna that Smilodon relied on for food began to die out, the saber-toothed predator found itself in an increasingly precarious position. The very adaptations that had made Smilodon such a successful hunter of large prey became a liability. It was too specialized to take down giants, and when those giants disappeared, it couldn't adapt. It's not even the massive sail rising from its back like some prehistoric fin. No. What truly unsettles you is how perfectly wrong everything about this creature appears, yet how devastatingly effective each bizarre feature proved to be. Start with that skull. A narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. But then Spinosaurus arrived, and death came from an angle you weren't prepared for. That massive sail on its back wasn't just for show. When Spinosaurus needed to move through shallow water, it acted like the keel of a boat, providing stability and control. This meant that even in areas where full swimming wasn't possible, it remained a perfectly balanced killing machine. It could move through water with deadly grace. Modern great white sharks inspire fear, but Spinosaurus had even longer to sharpen the same deadly craft, only with added intelligence, versatility, and sheer size that dwarfs any marine predator alive today. It wasn't just a hunter of rivers and lakes. It transformed every waterway it entered into its personal killing field. Those paddle feet weren't just for show either. They propelled Spinosaurus through water with surprising speed and maneuverability, allowing it to pursue prey through underwater mazes of fallen logs and vegetation. Unlike purely aquatic predators that relied on ambush, this nightmare could adapt its hunting strategy in real time. Miss your target underwater? Simply rise to the surface and snatch prey from above. Prey takes refuge in shallow water. Those webbed feet provided perfect stability for wading attacks. The hunting scenarios become even more terrifying when you consider Spinosaurus's intelligence. Crocodiles are clever hunters, but they operate on instinct. Spinosaurus possessed the problem-solving capabilities of a large theropod. This intelligence was applied to an environment where most prey had never faced anything remotely similar. Even more disturbing was how Spinosaurus turned the very act of drinking water into a death trap. For millions of years, animals had taken a calculated risk approaching rivers and lakes. But suddenly, the riverbank itself became unreliable. That submerged log might be a 50 FT predator. Those ripples might indicate the approach of something that could strike from below with the force of a freight train. The fossil evidence suggests Spinosaurus didn't just occasionally venture into water. It lived there, spending most of its time submerged, transforming ancient waterways into hunting territories more dangerous than any terrestrial predator could create. In a world where survival depended on understanding and avoiding threats, Spinosaurus represented something unprecedented. A predator that eliminated the fundamental distinction between land and water safety, merging them into a single inescapable killing field. And, like, we can't be talking about the perfect killing machine without mentioning its teeth. Conical, dagger-like, and built to clamp down on prey that thought the water would save them. Each one was angled backward like barbed hooks, creating a living fish trap built on a terrifying principle: easy entry, impossible exit. But the teeth were just the beginning of Spinosaurus's sensory arsenal. Recent studies suggest this predator possessed press-sensitive organs along its snout, much like modern crocodiles, but far more specialized. In murky river water, where visibility dropped to mere inches, Spinosaurus could detect the faint press waves of swimming fish from remarkable distances. Prey animals that relied on hiding in dark sediment-filled water were essentially sitting ducks against a hunter that tracked by feel rather than sight. Every movement in the water registered on Spinosaurus's pres sensors, allowing it to track multiple targets simultaneously, predict their movements, and position itself for killing strikes with mechanical precision. Those massive nostrils, positioned high on the skull like a crocodile's, allowed Spinosaurus to breathe while almost fully submerged, keeping most of its body hidden beneath the surface. The snout was covered in a dense network of tiny sensory pits specialized for detecting press waves and subtle water disturbances. In murky rivers, this system worked like underwater radar. I sometimes find myself haunted by images from deep time. Imagine a predator that combined the bone-crushing power of the largest land carnivores with the precision of an aquatic hunter. That was Spinosaurus. Its bite wasn't about single, devastating blows like a T-Rex. It was about steady, inescapable press. Those backward-curved teeth did their grim work constantly. The fossil record paints a picture of relentless killing. The sheer number of fish remains found alongside Spinosaurus fossils suggests a creature always on the hunt. Not just killing when hungry, but ceaselessly transforming waterways into active crime scenes. Death could strike from any angle, at any moment. 100 million years ago, what we now call southeastern Morocco was a totally different world. Lush rivers ess across North Africa, creating ecosystems of unimaginable abundance. Massive channels, swamps, and floodplains made this one of the most dangerous habitats ever. Every bend in the river could hide a predator beyond comprehension. This was the Kelenken Beds Formation, a prehistoric paradise that was, quite literally, hell on earth for anything trying to survive. Picture rivers deeper and wider than the Amazon, tropical forests stretching beyond every horizon, and air humming with the calls of creatures that would dwarf modern elephants. The climate was so warm that palm trees grew at what we'd now consider Arctic latitudes, and so humid that thunderstorms rolled across the landscape with mechanical regularity, feeding the endless network of rivers and swamps. In this steaming, river-choked ecosystem, Spinosaurus wasn't alone. The Kelenken Formation reveals that this aquatic terror shared its territory with a deadly mix of predators, prey, and rivals. It's not just the individual creatures that make this ecosystem remarkable, but how they coexisted in what might have been the most dangerous environment in Earth's history. On land, giants like Carcharodontosaurus patrolled inland areas, while Spinosaurus dominated the waterways. Sarasuchus, the 40-foot super croc, competed directly with it for aquatic hunting grounds. Mid-sized hunters such as Rugops cleaned up Spinosaurus's leftovers, while swift predators like Deltadroius and Behemoth used speed to carve out their place. Herbivores like Ouranosaurus, Rebbachisaurus, and the colossal Paralititan somehow survived this gauntlet. The waters themselves were far from safe, filled with monstrous prey. Every species in this ecosystem lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces. Herbivores relied on elaborate survival tactics just to drink, and aquatic prey developed increasingly tough defenses. The last Spinosaurus died approximately 94 million years ago. But the questions this creature raises about predation, dominance, and the very limits of survival continue to ripple through our scientific understanding, like press waves from some impossible prehistoric nightmare that refuses to stay buried in stone. When we think of prehistoric apex predators, our minds often drift to the iconic Tyrannosaurus rex or the fearsome megalodon. The discovery of complete skulls proved particularly revolutionary. These specimens revealed that while certain features resembled those of wolves, others were startlingly different. The skull. It's what struck me first. This wasn't like any dog I'd ever seen, or even read about. The skull possessed these enlarged premolars and this incredibly strong cranial structure. It looked more like a lion or a hyena than any kind of canine. It posed a real challenge for paleontologists, a question we had to answer. What exactly was this creature? The answer, as it often does, lay in the specifics. Those specialized premolars, that robust jaw, they pointed to something very specific, the Paraphysornis subfamily. This group, often overlooked, represents one of the most successful branches of the canid family. And what a diverse group they were. 66 known species, all with powerful teeth, shorter, deeper jaws, and a fifth toe, a feature lost in many modern canids. For over 15 million years, they dominated North America, evolving into an array of forms. Some were fox-sized, others rivaled or even exceeded the size of today's grey wolves. And then there was Epicyon, the ultimate expression of the bone-crushing dog. Its name literally means more than a dog. Recent studies of modern canids are helping us understand where Epicyon fits within the larger family. It seems the Paraphysornis were a highly specialized branch, following a unique path, distinct from the lineage that led to modern wolves and dogs. This specialization explains both its unique features and its eventual fate. Within the Epicyon genus, 3 distinct species emerged, each filling a different ecological niche: Epicyon savus, Epicyon haydeni, and Epicyon elodontoides. All were impressive predators, but they differed significantly in size and build. The smaller species, Savus and Elodontoides, were more gracile, built for agility and speed. Even these smaller species typically weighed twice as much as a modern German Shepherd. But Epicyon haydeni truly pushed the boundaries of canine adaptation. Recent studies of well-preserved specimens have revealed just how massive they were. Adults routinely reached lengths of 2.4 meters, nearly 8 feet, rivaling the length of a grizzly bear. They stood 90 centimeters, or 35 inches, at the shoulder, comparable to the height of a wild deer. Adults averaged between 125 and 170 kilograms, making them heavier than modern leopards and comparable to large jaguars. Some individuals reached weights of around 170 kilon, or 370 pounds, matching medium-sized male lions. That would make them the heaviest known canids ever to exist. But Epicyon wasn't just big. It had a bite to match. Biomechanical studies have revealed that it possessed one of the most powerful biting mechanisms ever seen in a mammalian carnivore. The enlarged premolars and strategically positioned canine teeth, closer to the jaw joint than in modern canids, created a highly efficient biting apparatus. Analysis of the skull architecture suggests that its bite force may have exceeded 16,000 newtons, comparable to that of large American alligators. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips during bites. It could easily pierce through thick hide, flesh, and even bone. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicyon used its formidable bite. These studies show distinctive patterns of wear consistent with both flesh-slicing and bone-crushing activities, suggesting a predator that could efficiently process every part of its prey. Fossil deposits indicate that Epicyon was an opportunistic predator, capable of taking down a wide range of prey. Their fossil remains have been found alongside ancient camels, pronghorns, horses, and peccaries. They even seem to have hunted prehistoric rhinoceros species like Teleoceras, which could reach lengths of 4 meters and weigh nearly 2 tons. Recent studies suggest that Epicyon may have employed different hunting strategies depending on prey size and availability. For smaller prey, they likely hunted alone or in pairs, using their impressive speed and power to quickly overwhelm victims. However, evidence increasingly points to the possibility that they also engaged in pack hunting, particularly when targeting larger prey. This idea of social hunting is supported by several lines of evidence. Nearly all well-studied modern canids exhibit some degree of social behavior, with most species showing higher levels of sociality than the average mammal. Additionally, most extant canids hunt cooperatively, with only a few exceptions such as foxes and some small canid species. The fossil record provides further support for this theory. Epicyon fossils are. I find myself drawn to the paradox of Epicyon, a creature whose very success may have sown the seeds of its demise. Here was a carnivore so well adapted to its niche, so capable of extracting every last bit of sustenance from its kills, that it thrived across North America for millions of years. Yet, those same specializations, the very traits that allowed it to flourish, may have ultimately led to its extinction. Epochian remains are among the most abundant carnivore fossils we find in North American deposits from that era. This suggests they lived in stable populations across their territory, a pattern we usually see in social predators, animals that hunt in packs. Looking at their bones, I can see that Epichion was built differently than most other canids, both living and extinct. They had a more robust skeleton, with heavier bones. The Miocene epoch saw significant climate fluctuations. During times when prey was scarce, being able to fully utilize every part of a carcass would have provided a crucial survival advantage. Epichion remains have been found in more than 10 different US states and parts of southern Canada. They thrived in a diverse array of habitats, from woodlands and savannas to grasslands and wetlands. The discovery of their remains in cave systems and edge environments suggests they were strategic in their habitat selection, preferring areas that provided both hunting opportunities and shelter. They were primarily carnivorous, but the structure of their teeth suggests they could also process tough plant material when needed. All of this combined would have allowed them to survive in a wide range of environments and through various seasonal changes. What I find so compelling is that the ultimate disappearance of Epichion from the fossil record has puzzled paleontologists for so long. Early theories pointed to competition from newly arriving big cats. But the big cats that would have competed with Epichion, such as Smilodon, didn't appear in North America until millions of years after Epichion's disappearance. The current evidence suggests that climate change was the primary driver of Epichion's extinction. The late Miocene saw significant global cooling and increased aridity, leading to fundamental changes in North American ecosystems. Paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also hunting strategies. Epichion's specialized adaptations, its heavy build, bone-crushing teeth, and relatively short legs may have become disadvantageous as prey species became faster and more adapted to open environments, unlike their more generalized relatives, which gave rise to modern wolves and other canids. Epichion's extreme specializations may have limited its ability to cope with these changing conditions. The discovery of Ankylosaurus magnaventris wasn't just a milestone for paleontology. It was like opening a window into the intricate design of one of nature's most formidable creatures. I remember when I first saw the images of those bizarre armor plates, robust bones, and distinctive teeth. It was clear this was something that would our understanding of dinosaur defense mechanisms. The name itself tells a part of the story. Ankylosaurus, meaning fuse lizard, refers to its remarkably fortified skeleton. Magnaventris translates to great belly, highlighting its distinctively broad midsection. In 1906, Barnum Brown of the American Museum of Natural History led an expedition through Montana's Hell Creek Formation. Among the layers of Cretaceous sediment, he unearthed an assortment of fossils that perplexed him at first glance. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, belonging to the larger clade Ornithischia, were characterized by their extensive armor plating and herbivorous lifestyle. Within this group, Ankylosaurus belonged to a more specialized family, the Ankylosauridae, distinguished by their massive triangular skulls, stocky builds, and elaborate defensive features. But among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered, with adults reaching lengths between 5.4 to 10 meters, or 17 to 33 feet, and standing about 1.7 meters at the hip. More impressively, these titans weighed between 5 and 8 tons, surpassing even the famously robust Triceratops in mass, and rivaling the earlier aquatic predator Spinosaurus. One might wonder how a relatively low-slung animal could pack such impressive weight into its frame. The answer lies in its extraordinary construction. Imagine a biological tank meticulously designed for strength and survival. The Ankylosaurus's skeleton was built unlike any other dinosaurs, with dense, compressed bones forming a sturdy foundation for what would become one of nature's most sophisticated armor systems. Recent studies of its bone structure have revealed something fascinating. The bones themselves were uniquely reinforced with internal struts and buttresses, similar to the architectural principles used in modern building construction. Unlike other armored dinosaurs that had solid, thick plates, the Ankylosaurus possessed something more sophisticated: osteoderms with hollow undersides. This seemingly counterintuitive design actually represented a remarkable feat of natural engineering. The hollow structure created a dome-like formation that distributed impact forces more effectively than solid plates would have, similar to how modern motorcycle helmets use their curved design to protect riders. This adaptation made the armor particularly effective. The tail club of the Ankylosaurus wasn't just a simple bony growth. It was a precisely engineered weapon, one of nature's most effective deterrents against predation. Recent CT scans of those tail club fossils have revealed an intricate internal structure, optimized for both strength and swing speed. The club itself was composed of two large osteoderms at its core, complemented by smaller ones at the tip and along the midline, all supported by a framework of highly modified vertebrae. This was specifically adapted to handle the stresses of high-speed impacts. The mements are staggering. Specimens show the club could reach 57 centimeters in width, weighing approximately 23 kilos. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons, achieving swing impulses of up to 4,800 newtons per second. To put this in perspective, while a professional baseball player generates about 13 newtons per second in their swing, the Ankylosaurus's tail strike was 370 times more powerful. Recent studies using finite element analysis have even suggested that the impact force could have been focused on an area as small as a few square centimeters, multiplying its bone-crushing potential. Beyond the club, the Ankylosaurus's armor was also quite remarkable, particularly effective against the crushing bite force of predators like T-Rex, whose hunting strategy relied heavily on delivering powerful bone-crushing bites. Beneath these armored plates lay a network of collagen fibers that puts modern protective materials to shame. These fibers, significantly thicker than those found in modern armored animals like crocodiles and armadillos, created a natural composite material similar to modern fiber-reinforced plastics. Recent biomechanical studies have shown that this combination of hard plates and flexible fibers could absorb and dissipate energy from impacts in ways that purely rigid armor couldn't match. In fact, when subjected to simulated impact tests, reconstructions of Ankylosaurus armor proved capable of withstanding forces that would have seriously injured or killed most other dinosaurs. The behavior and lifestyle of Ankylosaurus were as unique as its anatomy. While much of its life remains a mystery, fossil evidence offers glimpses into its daily routines and survival strategies. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center, a defensive strategy reminiscent of modern muskoxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Adults appear to have been predominantly solitary, a conclusion supported by the rarity of adult specimens found in groups. Their solitary behavior was likely a reflection of their formidable defenses, which allowed them to traverse their environments without fear of predation. Solitary adults might have roamed large territories, primarily in search of food and suitable habitat, avoiding direct competition with other herbivores. Some paleontologists have speculated that Ankylosaurus might have used its tail club for intraspecific communication or dominance disputes. This theory is supported by observations of similar behaviors in modern animals with physical weaponry, such as bighorn sheep or rhinoceroses. The display of their tail clubs, combined with body size and posturing, could have deterred rivals without escalating into physical conflict. However, the evidence remains inconclusive, and further fossil discoveries may provide clarity on this aspect of their behavior. Ankylosaurus thrived in the rich and dynamic ecosystems of late Cretaceous North America, particularly in regions that would later become known as the Hell Creek Formation. This area was a mosaic of environments ranging from subtropical forests to open floodplains teeming with diverse flora and fauna. Fossilized plant remains suggest Ankylosaurus inhabited regions with abundant low-growing vegetation, which suited its low-slung, round grazing body. The climate of the late Cretaceous was warmer and more humid than today, which supported lush forests dominated by conifers, cycads, and ferns. Ankylosaurus likely played a role in shaping this ecosystem, though not as extensively as herding dinosaurs like hadrosaurs. Instead, its selective feeding habits might have influenced plant growth patterns in localized areas. The association of Ankylosaurus fossils with specific types of vegetation has led researchers to hypothesize that they may have helped disperse seeds, inadvertently promoting plant diversity. Seasonal changes would have impacted the behavior of Ankylosaurus. Fossil evidence indicates that some regions experienced dry and wet seasons, influencing the availability of food resources. Ankylosaurus may have adapted by modifying its diet or undertaking small-scale migrations to follow vegetation growth. The robust construction of its body, coupled with its ability to consume tough plant material, would have allowed it to survive in less than ideal conditions. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its presence in these environments exemplifies. I find myself often pondering the delicate balance of ancient ecosystems. Consider the Ankylosaurus, a creature whose very existence hinged on a finely tuned food web. Its diet, primarily herbivorous, showcases remarkable adaptations for processing tough, fibrous vegetation. Its broad, low-slung muzzle and simple ridge teeth were perfectly suited for stripping ferns, cycads, and horsetails. Unlike some herbivorous dinosaurs with elaborate dental batteries, Ankylosaurus relied on its powerful jaw muscles to break down plant material. Recent studies have even revealed wear patterns suggesting a surprising degree of dietary flexibility. While vegetation was its mainstay, it may have occasionally supplemented its diet with protein-rich fungi or small invertebrates, much like modern tortoises and iguanas do today. The digestive system of Ankylosaurus likely included a large, complex gut capable of fermenting plant material, a necessity for extracting sufficient nutrients from its fibrous diet. Fossilized coprolites from similar species suggest the presence of symbiotic gut bacteria, playing a crucial role in breaking down cellulose and producing energy-rich byproducts. It's fascinating to consider that Ankylosaurus's broad midsection may have been a specialized design to house this extensive digestive system, providing ample space for fermentation and nutrient absorption, ensuring the animal could thrive on a diet of relatively low-calorie plants. This, combined with its sturdy build and slow metabolism, likely made it an efficient grazer, well suited to its environment. Beyond its diet, the sensory capabilities of Ankylosaurus were equally remarkable. Its most prominent feature was its highly developed sense of smell, vital for locating food, avoiding predators, and perhaps even detecting mates. Fossil evidence reveals that the olfactory bulbs in its brain were unusually large for an herbivorous dinosaur, suggesting a sense of smell comparable to many modern reptiles and mammals. Advanced imaging techniques applied to Ankylosaurus skull fossils have revealed intricate nasal passages, likely serving a dual role, enhancing its olfactory capabilities and aiding in thermoregulation. The convoluted structure of these nasal cavities, creating a larger surface area, may have allowed Ankylosaurus to cool or warm incoming air, helping it adapt to the varied climates of the late Cretaceous period. Vision and hearing also likely contributed to its survival. Around 82 million years ago in North America, the world witnessed the emergence of Deinosuchus, the largest crocodilian in Earth's history. This colossal creature whose name translates to terrible crocodile, was discovered in the 1850s when large distinctive teeth were unearthed in North Carolina. Initially, these teeth were mistaken for those of a plesiosaur, a type of marine reptile, leading to considerable confusion among paleontologists. However, they quickly realized that this creature was massive and imposing. The sheer size and unique characteristics of the teeth did not align with known marine reptiles, prompting a deeper investigation. Dr. Joseph Leidy, a leading paleontologist of the 19th century, played a pivotal role in re-evaluating these remains. His meticulous examination and publications corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. The newly proposed classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Deinosuchus hacheri. I've always been fascinated by creatures that defy expectations. Deinosuchus, the giant crocodilian, certainly fits that bill. Early claims suggested they could reach almost 50 feet in length and weigh over 10 tons. While those initial estimates were a bit exaggerated, the reality of their immense size remains awe-inspiring. Unlike some species whose sizes get revised downwards over time, Deinosuchus has retained its colossal stature. New findings continue to confirm just how massive these ancient reptiles truly were. There are 3 recognized species: Hacheri, Rugosus, and Riograndensis. Deinosuchus hacheri, found in North Carolina, offered our first critical insights into the genus. Then came Deinosuchus rugosus, discovered mainly in Montana, displaying a more robust build, perhaps adapted to different prey or environmental conditions. And finally, Deinosuchus riograndensis, uncovered in Texas, a lineage that grew even larger than its eastern relatives. The remains of Riograndensis were more plentiful and better preserved, giving us a clearer picture of their lives. Paleontologists now estimate that the average adult Deinosuchus measured between 26 and 33 feet in length and weighed between 2.5 and 5 tons, more than twice the size of a male hippo. Some individuals grew even larger. Among the known specimens, the Riograndensis species truly stands out. Detailed studies of these remains, primarily found in Texas, suggest that the largest individuals could reach lengths of up to 12 meters, almost 40 feet, and weigh around 8.5 tons. That would make them not only the largest crocodilians ever to have lived, but also heavier than most dinosaurs, save for the tyrant king, Tyrannosaurus rex. I remember reading the work of paleontologist Thomas Lehman, who extensively examined the Texas fossils. His insights into the biology and growth patterns of these ancient reptiles were fascinating. He discovered growth rings in their osteoderms, much like tree rings, offering valuable information about their age and growth rates. The largest Riograndensis individuals showed evidence of rapid growth spurts during their juvenile years, followed by a more gradual growth into adulthood. This underscores how environmental factors, like food availability and climate, significantly impacted their growth and maximum size. In many ways, Deinosuchus resembled modern alligators, with a similar body and snout. But beyond this general similarity, Deinosuchus possessed a unique skull shape unlike any other living or extinct crocodilian. The skull was exceptionally large, measuring up to 1.7 meters, or 5.6 feet, in length, comparable to that of an adult Spinosaurus. Despite its size and robust build, studies suggest that Deinosuchus's bite force was, surprisingly, somewhat modest. A 2002 study reported a bite force of about 18,000 newtons, sufficient to crush bones, but relatively weak considering its size, especially compared to the smaller saltwater crocodile. But when I examined the fossils, the skull told a different story. It was not only massive, but also highly specialized. The arrangement of its teeth revealed a combination perfectly adapted to its predatory lifestyle: conical and sharp front teeth for grasping prey, and blunt, robust rear teeth designed for crushing bones. Reconstructing the hunting methods of Deinosuchus involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, strong neck muscles and a sturdy body, certainly support this hypothesis, painting a picture of a highly effective predator in its ancient ecosystem. Interestingly, Deinosuchus experienced a slow growth rate, evidenced by growth rings on its osteoderms, those bony plates that served as armor. These rings indicate it took around 35 years to reach full size. Despite this long maturation period, juvenile Deinosuchus were still formidable predators, sporting considerable size and powerful bites even at a young age. These osteoderms not only served as armor, but also supported the animal's massive body, increasing its load-bearing capacity and enabling efficient movement on land despite its size. Deinosuchus was a highly successful predator, evidenced by its extensive range, with remains found throughout the United States and northern Mexico. During its prime, the American continent was divided by the Western Interior Seaway, a shallow sea, and Deinosuchus thrived on both sides. It inhabited diverse environments, including estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, though some believe that the marine remains could have been displaced post-mortem. Its extinction marked the end of an era, but the fossil remains of Deinosuchus continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. And yet, the ancient world continues to surprise me. In the world of big cats, the tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate apex predator. But there's one ancient beast that towers above them all: the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. This isn't just another big cat. It's a legendary predator that dominated its world like no other, leaving modern felines in the dust. The story of this magnificent creature's discovery begins in the humid lands of Mississippi during the early 1800s, when paleontologists first unearthed fragments of its skull. Initially, they believed they had found remains of an unusually large domestic cat, placing it in the genus Felis. This classification, however, would prove to be just the first chapter in a much longer story of scientific discovery and reclassification. As more specimens emerged from the Earth, scientists quickly realized they were dealing with something far more impressive: the sheer size and distinctive features. The American lion. Even the name conjures up images of immense power, a true apex predator roaming the ancient landscapes of North America. But what I find most striking is how recent discoveries have reshaped our understanding of this magnificent creature. It wasn't just a subspecies of the modern lion, as once believed. It was something far more unique, far more formidable. These weren't simply overgrown lions. Detailed anatomical studies revealed key differences. A more robust build, proportionally longer limbs, and, notably, the absence of a prominent mane in the males. This led to its reclassification as its own species, Panthera atrox, the cruel panther. DNA analysis suggests they descended from an isolated population of cave lions, trapped south of the North American ice sheets, roughly 340,000 years ago. This isolation, during the Pleistocene epoch, spurred rapid adaptations to the unique North American environments. While modern lions are their closest living relatives, the last common ancestor lived between 500,000 and almost 2 million years ago. It's a testament to how quickly nature can adapt. The sheer size of the American lion truly sets it apart. They averaged about 25% larger than today's African lions. Male American lions typically weighed between 351 and 420 kilograms. But some specimens discovered in 2012 tipped the scales at an astounding 523 kilograms. That's like 8 adult humans combined. Even the largest Siberian tigers, the biggest living cats today, rarely exceed 300 kilograms. The only real-size competitor was the Smilodon populator, which could reach up to 470 kilograms. But those exceptionally large American lion specimens found in 2012 firmly established Panthera atrox as the heavyweight champion of the feline world. What's remarkable is that despite their enormous size, they maintained the agility and speed characteristic of big cats. Conservative estimates suggest they could reach speeds of over 30 miles per hour, faster than any human athlete. This combination of size and speed would have made them extraordinarily effective predators. Their hunting strategy likely relied heavily on ambush tactics. This conclusion is drawn both from their anatomical features and the hunting behaviors of their modern relatives. Their robust bone structure and powerful muscles would have allowed them to quickly overwhelm large prey, while their long legs provided the burst speed necessary for successful ambush attacks. Fossil evidence offers compelling insights. Take Blue Babe, a remarkably preserved steppe bison in Alaska, bearing the unmistakable marks of an American lion attack. Deep claw wounds and distinctive bite patterns matching the predator's dentition. Then there are the fossils from sites like Natural Trap Cave in Wyoming, where numerous prey species bear the characteristic damage patterns of American lion predation. But what truly set them apart wasn't just their size. It was their exceptional adaptability and territorial dominance. Studies of fossil deposits across North America reveal fascinating insights into their social structure and hunting territories. Unlike modern African lions that typically control territories of 100 to 200 square kilometers, American lions commanded vastly larger ranges, some extending up to 500 square kilometers per pride. This massive territory was a necessity, given their enormous size and corresponding caloric needs. The fossil record also tells us about their social dynamics. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller, but more efficient. Bone assemblages at sites like the Page-Ladson site in Florida and the Rancho La Brea deposits suggest groups of 4 to 6 adults working together with devastating effectiveness. Their smaller pride size, combined with their larger individual mass, meant each pride needed to bring down fewer but larger prey animals to sustain themselves. Perhaps most fascinating is the evidence of their den sites discovered in caves across the American West, particularly in the Grand Canyon region. These sites show signs of multi-generational use, some caves bearing marks of occupation spanning thousands of years. They adapted to grasslands and semi-forested regions, sharing their territory with mammoths, mastodons, and early humans. Cave paintings hint at their lasting impression on human cultures, maybe even influencing early American art and mythology. Then, about 12,877 years ago, it ended. The extinction event that claimed so many of North America's large mammals. Climate changes, reducing prey, and increasing human press, a combination that pushed these magnificent predators past their breaking point. But let's shift our gaze skyward now to another prehistoric ruler. Imagine an enormous creature soaring overhead, its massive wings casting a shadow, sending potential prey into a chaotic frenzy. This is Quetzalcoatlus. Discovered in Texas in 1971, the paleontologist who found it was so mesmerized by its size that he named it after an Aztec serpent god. And then, in a nod to modern marvels, he added Northropi after an aircraft manufacturing company. This creature has become known as the largest pterosaur and the largest flying animal in history. Despite cohabitating with the Tyrannosaurus rex, so little is known about its biology. Its wingspan, initially thought to be broader than an F-22 fighter plane, is now estimated to be between 10 to 12 meters, still larger than an F-16. It stood roughly the same height as a giraffe. While another species, Hatzegopteryx, may have been larger in weight, Quetzalcoatlus remains the largest pterosaur to have flown over North America. Almost all paleontologists now agree that it was capable of flight. Recent discoveries have revealed that Quetzalcoatlus had remarkably light, almost potato chip-like bones, which would have made flight much easier than previously imagined. This revelation, however, opened up a whole new set of questions. How did Quetzalcoatlus take off from the ground? And how exactly did it fly? Several theories have been proposed, describing this enormous reptile leaping into the air by flapping its wings or lurching forward on its wingtips, much like a vampire bat. In some scenarios, it might have crouched low before launching itself as much as 8 feet into the air, giving it enough space to spread its wings and take flight. Its strong hind legs would have provided the massive push needed for such a jump. One study suggested that Quetzalcoatlus was actually a remarkable flyer, engaging in brief bursts of powered flight before gliding. It could potentially reach a top speed of 130 kilometers per hour, or 80 miles per hour, and sustain this for perhaps 7 to 10 days, giving it an extraordinary flight range. Despite its overall bulk, the torso of Quetzalcoatlus was surprisingly dense and packed with massive muscles. These giants could likely take off with a single leap and maintain altitude with only a few flaps of their wings. Once airborne, they could potentially fly non-stop for 16,000 kilometers, flapping only occasionally to maintain altitude and course. Their short wings were composed of tightly packed muscle fibers called actinobrols, which provided both flexibility and strength, allowing for precise adjustments in the air. The remarkable flight capabilities of Quetzalcoatlus even inspired a Johnson Wax-sponsored mission to construct a model flying machine to test flight simulations. The model, about the size of Quetzalcoatlus lawsoni and equipped with a basic computer for autopilot, successfully demonstrated soaring and flapping flight. Interestingly, Quetzalcoatlus and other Ajdashids had hind limb proportions more similar to modern running ungulate mammals than to their smaller pterosaur cousins, suggesting they were uniquely adapted to a terrestrial lifestyle, even though they were quadrupeds when on the ground like other pterosaurs. This has prompted scientists to further investigate the lifestyle and feeding habits of Quetzalcoatlus. It's generally accepted that this flying giant was a carnivore, but its exact diet has been the subject of much speculation. Douglas Lawson, who first discovered Quetzalcoatlus, initially suggested it scavenged on the carcasses of titanosaur sauropods, much like a marabou stork. He reasoned that scavenging was the only viable option, as the fossil was found far from the coast, with no evidence of large rivers or deep lakes nearby during its lifetime. However, this scavenging theory was challenged in 1996. For a time, Quetzalcoatlus and its relatives were viewed as giant vultures scavenging the carcasses of dinosaurs and other dead animals. But with ongoing research and scientific advancements, we're beginning to gain a clearer picture of the habitat of this unique creature that once dominated the skies of the late Cretaceous Maastrichtian age of North America. Quetzalcoatlus most likely inhabited a variety of environments during the late Cretaceous period, including coastal regions and inland plains, landscapes that would have provided ample opportunities. The thought of encountering Quetzalcoatlus, it makes me grateful to live in a time beyond their reign. Imagine a world where the skies were dominated by creatures with wingspans rivaling small aircraft. Quetzalcoatlus northropia, that solitary hunter of the inland, must have been a terrifying sight. It's believed this giant coexisted with other colossal creatures. Fossils hint at the possibility that they shared their world with creatures resembling Tyrannosaurus and Torosaurus, though conclusive studies are still needed. Alongside the Alamosaurus, Quetzalcoatlus may have crossed paths with other herbivorous giants and fearless predators. We're talking about the mighty T-Rex, Dromaeosaurus, Triceratops, Albertosaurus, Edmontosaurus, and Dakotaraptor. In the skies, Quetzalcoatlus likely shared the space with other pterosaurs, such as Pteranodon and Nyctosaurus, coexisting within those now extinct ecosystems. The landscape offered Quetzalcoatlus several options for hunting, nesting, and roosting. It's quite possible that Quetzalcoatlus lawsoni lived in swarms around alkaline lakes, as they were thought to be sociable, wading birds.